Hi, my name is Nana Yang from UC Leuven, and I'm representing our work using pure pollen species when training a CN to segment pollen mixtures. Recognizing the types of pollen grains is important for agricultural, medical, and ecosystem research because annotating pollen mixtures is time-consuming and requires considerable recognition expertise. We hope to train a CN model that recognizes many pollen species without having to annotate many images with many species. In our work, a method is proposed to learn how to segment individual pollen species in pollen mixtures based on a large dataset composed of images with single pollen species. To save manual annotation time, our method first trains a universal pollen segmentation CN based on the semi-manual segmentation of pollen grains. This model is then used to automatically segment a large number of additional pure pollen images so as to supervise the training of our multi-species segmentation CN. A total of 149 pure pollen files with inconsistent backgrounds. Each file corresponds to a large-scale image. Some of them have resolutions over 30,000 by 30,000. Each pure pollen file includes a single species of pollen. Large-scale images implies higher computational and memory requirements during model training. Therefore, we crop a large-scale image into multiple 800 by 800 images, as shown in Figure 1. Figure 2 is the overview of our method. In order to solve the tedious task of labeling large datasets, we first semi-manually segment foreground pixels, that is the pollen grains, on a small set of images using the graph cut algorithm. Then we use the resulting annotations to train a universal pollen segmentation model. Our universal pollen segmentation CN consists in a 9-layer unit, followed by 2 output filter maps connected to a sigmoid to predict a binary value in each image pixel. The CN adopted to recognize and segment pollen species in pollen mixtures is a similar unit backbone. In practice, one output map is devoted to each of the 3 possible categories that the model is expected to recognize. A softmax operator is applied to the 6 activations outputted by the network in each pixel, so as to predict a vector with positive components that sum to 1. Each of these vectors is close to one hot vector that is supposed to encode the category of its corresponding pixels. 2 types of pollen species segmentation of CN have been envisioned in our study as shown in Figure 3. Depending on how they define the output categories, they aim at recognizing. The first one, named the non-pollen species, KPS, is certainly the most natural. It assigns one specific output to each of the unpollen species represented in the training set. The second strategy, named the unknown and non-pollen species, UKPS, it proposes to partition the unpollen species into disjoint subsets and to learn a model for each subset, thereby leading to different family models. As a baseline, we consider a combination of UPS and KPS. The approach is depicted in Figure 4. The UPS model predicts whether a pixel is part of a pollen grain or not. Instead, KPS differentiates the non-pollen species and is supposed to assign pixels that do not correspond to a known species, either because they correspond to background or to an unknown pollen species, to the additional bin class of KPS, hence as shown in Figure 4. Combining the predictions from UPS and KPS should make it possible to identify unknown pollen species, which are the pixels labeled as the pollen by UPS and background by KPS. For convenience, here we name the family-specific UKPS models based on the first letter of the corresponding family name. Fig 5 shows the predictions of 5 unknown pollen species. The KPS of baseline is supposed to assign a background label to pixels that do not correspond to a known pollen species, either because they correspond to background or are unknown. We, however, observe that KPS segments unknown species as known types rather than the background. In contrast, each UKPS model appears to successfully segment unseen species into the appropriate unknown class. Fig 6 considers the segmentation of pollen mixtures and shows the ground truth and the corresponding prediction for the image containing two pollen species. One is known by A model and the other is known by F model. Although the central region is misclassified as background, it is reasonable because our mixture pollen images and the pure pollen images used for training have been collected and observed with different setup, which results in significant visual differences between the scan samples provided by biologists. The discrepancy between training and test images is illustrated by the images presented in Fig 7. To provide a quantitative evaluation of our method, we have tested the baseline and the 5 UKPS models. Table 1 presents the LU of background and unknown category on the 18 absolutely unknown species. The results show that our proposed UKPS can segment unknown pollen species well compared with the baseline. The LOU of each class is shown in Fig 8 and Fig 9, generated based on test images that only contain pollen species that are available at training. We observe that, in general, most of the species that each UKPS model can see in the corresponding family has a slightly higher LOU than the baseline. And what is important is that the UKPS model can identify unknown species well, and the baseline can theoretically identify unknown pollen types, but experiments show that it fails. In conclusion, the UKPS we proposed can successfully assign pollen species unseen by the model into unknown class rather than known classes. The resulting model is shown to provide accurate segmentation of species, including in pollen mixtures. Our experiments also demonstrate that dedicating a model to the segmentation of subsets of pure pollen species available at training makes it possible to train a main pollen class dedicated to all pollen classes, including the one unavailable at training that are not part of the model-specific subset of species. Thank you for listening to my presentation. If you have any queries, you can contact me by this email.